Hey pre-calc students, this is just a quick video of the first 4 questions of the 1.8 practice. I chose to put these in your new homework assignment because they are the most missed questions that I've seen in the last few assignments. So let's just make sure you guys really understand. If you notice, they're asking me to work with function f of x. So the first thing that you want to do is pay very close attention to what kind of function f of x is and any restrictions. Notice that they don't want this whole parabola, they want just the piece. So remember, we looked at this type of domain restriction when we looked at piecewise functions. So they just want the piece that's to the left or less than or equal to 2. Alright, so this parabola is shifted right 2 up 4. Right 2 up 4. I'm going to go ahead and follow the pattern of left 1 up 1, left 2 up 4. But I'm not going to graph the rest of the parabola because they said to the left, so less than or equal to 2. All right, the domain is based on the x values. So the domain is forever to the left, so negative infinity is on the left, positive infinity is on the right. So you want the lowest value first. So it goes forever to the left because this parabola is going to get wider and wider, so it's going to go more and more towards the negative x values. And 2. Stops exactly at 2. The range is based on the y values. You want to give the lowest y value, which is 4, and then the function goes towards positive infinity on the y-axis, not negative infinity. So it's from 4 to positive infinity. Okay, now they want us to write the equation of the inverse of f of x. So make sure that when you write your final answer, that you also pay attention to the restriction that was originally given in the function, okay? Because we're not finding the inverse of the entire parabola, we're just finding the inverse of the piece that was to the left of 2. So the piece that was x less than or equal to 2. All right, so to find the inverse, you replace f of x with y, and then you switch the x and y. By definition, inverses, in all of their ordered pairs, the x and the y values are reversed. Now you solve for y. So when you're solving for y, you're using SADMAP, so it's PEMDAS backwards. So you cancel addition and subtraction unless it's in a grouping symbol like parentheses, then you do it last. So I'm going to go ahead and cancel the minus 4. It's not a like term with x, so I'm going to keep them separate and write as x minus 4. Okay, there's no multiplication or division, but there is an exponent, so I'm going to go ahead and square root both sides to get rid of the exponent that is squared. But when you are solving and you square root something, there are 2 answers. There's a plus and a minus, so you need to put plus or minus square root of x minus 4. On the right side, you'll just have y minus 2. Okay, and the last step is to cancel anything that's in the parentheses or grouping symbol. I've got subtraction, so I'm going to add it. And that's going to be, again, not a like term with what's already there. Now, there are 2 answers here, but only one is the correct answer for the inverse. Notice that this is a square root, one that opens up and one that opens down. Which of those is the correct inverse to the function f of x? You can use a process of elimination by graphing both options and then erasing the one that doesn't work, or you can look at the domain and range of the original function and remind yourself that the inverse, okay, so the inverse has to have the domain becomes the range. Oops. So you don't flip the negative infinity into it. You just, the domain becomes the range because it's not an ordered pair. So you don't actually flip the negative infinity and the 2 because it's not an ordered pair. The domain becomes the range, the x's become the y's, and the y's become the x's. So according to this, I want the square root that's to the right of 4 and that goes down forever, down to negative infinity, and the highest that it goes is 2. So which one would it be? Would it be the square root at 4? So notice that this is right 4 up 2. Would it be right 4 up 2, the one that opens up, or the one that opens down? Which would follow the domain and range that we said it should have? Now, if that's not enough to help you decide, so that should be enough to help you decide that you want the one that opens down, that points down. So that's negative infinity, so that should be this guy. Okay? I'm going to put that in my answer before I forget. And I'm going to name it appropriately, so this is f negative 1 of x. Now, how do I know this is really the correct answer? Well, look at your original ordered pairs for your first half of the parabola. It was 2, 4, 1, 5, and 0, 8. According to the rule of inverses, I should have those same ordered pairs in the inverse, but in reverse order. 4, 2, 5, 1, and 8, 0. If I had chosen the one that opened up, those would not be the same ordered pairs as what my original one was, but with reverse order. So when you're trying to decide whether you want the plus or the minus after you square root, remember you square root, you put plus or minus. When deciding which one to pick, you can use the domain of the inverse to help you decide, or you can just reverse all the order of the ordered pairs from f of x, graph them, and that will help you decide that you need the negative one, the one that opens down. Okay, so in number 2, the one that we just did right here, we were using SADMET because we were solving for y. But when you're doing composition of functions, you're actually using regular good old PEMDAS. Please excuse my dear Aunt Sally. We're not solving for x, we're simplifying. And anytime you're simplifying or evaluating, you're using the regular order of operations. So they want us to do two things. They want us to set up f of g of x and g of f of x. So I'm going to take the f function. So I'm going to color code here, okay? So I'm going to take the f function, copy it, but then replace the x with g of x. I didn't give myself enough room. I hate when I do that. Okay, so instead of x, I'm going to go ahead and replace. So this guy x, I'm going to put g of x. All right, so remember, you're plugging one function into the other. I'm going to simplify, so I'm going to do whatever's in the parentheses first. I'm going to go ahead and cancel these two because they're both outside of the root. Then I'll be left with the cube root of x plus 1, quantity cubed minus 1. The cube root and the cube cancel. Notice the process. I had to cancel all the stuff outside of the root first before I could cancel the root. So I'm simplifying, and then I get left with x plus 1. There's no multiplier out here that I need to distribute. If there had been like a 5 or a negative 2, I would have had to distribute it to both x and 1. And then bring down the 1. Positive 1 and negative 1 cancel, and we get x. So this is looking promising. It looks like we might have inverses. Remember, if f of g of x and g of f of x equal x, they're inverses. Now I'm going to take the g function and replace the x with f of x. Okay, this is one big grouping symbol, this big root. So I need to simplify what's inside first. Some of you guys canceled the root with the cube in there, but you can't do that unless the cube is the only thing that's left inside of the root. So just like you can't square root until x squared is by itself. Okay? So you can't cube root unless there's only a quantity cubed inside the root. Right now you have a quantity cubed, but then some other stuff. So simplify that first before you cancel the root. So we're following the order of operations. So you have to make sure that you do everything inside the grouping symbol. So in PEMDAS, parentheses really stands for grouping symbols, and the root is one big grouping symbol. So you got to do the stuff inside first. Again, that was a common mistake. Some of you guys try to cancel the root right away, and you can't do that. Now, since there's a quantity cubed, and I'm cube rooting it, they cancel, the root and the exponent. And it turns out that these two functions are, in fact, inverses. All right, guys, if you have any other questions, make sure you reach out to me, send me a message on Remind, and I'll do my best to get back to you as soon as possible so that I can answer your questions. Have a great day.